Part 2, systems of linear inequalities. So in a system, guys, instead of just one line, you're going to have two lines, okay? So let's just say you see this, okay? Now, what I want you to do for shading to make it a little bit easier for you is don't draw so hardly, especially if you're using a pen, okay? What I want you to do is maybe just draw some lines like this when you're shading, so I know where your answers are, okay? Especially with pens, because I see some of you guys using pens and that's kind of run out of ink pretty quickly. But the reason, more importantly, I want you to do this is when you draw two lines, it's going to get hard to tell. But if you draw lines like this, okay, you're using less ink, and I can clearly see where you're shading, and I clearly see where your answers are. Because in a system, what you're going to see is you're going to see overlap. You're going to see this shading and this shading overlap each other in this section up here. And when they do that, what that means is, guys, this is where your answer is, right here. The space in between here and here, that's where I care about. That's where your answers are. When it has to be a system, one spot is not enough. This is not where your answers are. This is not where your answers are, because these are for the lines separately. There's no answers at all here. This is when your answers are the same. So that's what I want it to look like. Now, one of your questions is, can you write the inequalities? So let's do this. For this pink line, remember, you're using this as your model. You're using mx plus b. Our starting point, your y-intercept, is 1. Your slope, up 1 over 1. So you have a slope of 1. So you don't have to write that down. You can just write down x. But now, don't use an equal sign. What kind of line did they draw? Where is it shading? Well, it's shading above, so I should write down y is greater. Is it a solid or a dashed line? It's solid, so I'm going to draw that, and that's how you write it. Here, for this green one, it starts at 3, so that's my intercept. The slope is going down 2 over 1, down 2 over 1, so negative 2x. I don't need to put the 1 there. And again, don't put an equal sign. What kind of line is it? Where is it shading? Well, this is actually shading above the line, up here. So it also is greater than, but it's not equal to because the line is dashed. And this is what your answer should look like. If you're asked to write the inequalities, you're writing two different inequalities as your answers, okay? Now, if you're asked to graph them, you're doing the same thing. Just, take your time. So like, for example, here, I start at 4. 1, 2, 3, 4. My slope is negative 2/5 down to 1, 2, 3, 4, 5. It is going to be a dashed line. And I am shading y is greater above. So I'm going to shade up here. Okay. All right. Now here's another problem. I can't graph that. I need to change the way that looks. So I need to take 3x minus 4y greater than or equal to 12, and I need to change it to make it look like this one, y mx plus b. I'm going to start by moving 3x. I move 3x. I get negative 4y is greater than or equal to negative 3x plus 12. I need to divide by negative 4. Now this is important. When you divide by a negative 4, everything is being divided by negative 4. Now the y is a positive, because negative and negative. My slope is positive, and leave it as a fraction, but my starting point is negative. Now here's another important thing. Because you changed all the signs, these negative numbers are now positive. This positive number is now a negative. This sign has to flip. You have to switch the direction. That's whenever you are changing a problem. If the last step, if you're dividing with a negative number and you're dividing everything negative, you're going to change all the signs, including the inequality sign. Okay, so let me make this a different color. This starts at negative 3. My slope is up 3 over 4. It's going to go like this. It's going to be a solid line. And it says y is less than, so I'm going to shade below. Okay, where is my overlap? My overlap is right here. So what you should do is just darken where that happens. And that's where your answer is. Your answer is there. Okay, so just be careful when you have to rewrite inequalities to remember sometimes you have to change the signs. Now, what if you have a word problem? So I'm taking the problem that we did earlier about the water. In case you didn't watch the video, which you should have, I don't know why. We had a $90 budget, $4 water, $6 sodas. We found out if you split them perfectly, you can buy 9 cases of water and 9 cases of soda. You get 18 cases. Now, what if there's a new element involved? What if this wasn't enough? What if they come back to you and say, no, we need some more drinks. Can you buy 19 cases? Well, you don't change this formula. This is still for the price. What they want is the number of cases. So what you do is you write a new inequality, x plus y, and you want this to be at least 19 cases. Because you still can't go over budget, right? You can't buy more than 19. They want you to have more. So what you have now is a system of linear inequalities, okay? And you can graph these, okay? Now, what you then do is you have to change them, right? You can't leave it this way. So you rewrite it, and I think we rewrote this one already. Yeah, in our notes earlier, we rewrote the first one. Move the 4x divided by 6. We get this equation. So we get, sorry, let me do a little arrow here to change them. So this one is y is less than or equal to negative 2/3 x plus 15. Now this one's a little easier to change because you're only moving the x. And if you only move the x, you don't change any signs because you're not dividing. You're just subtracting x from one side, moving it to the other. The x cancels out. You're going to have that over here with 19. Then you take this to a graph. You would graph this. Now, a lot of the times with these word problems, guys, because we're dealing with the real world, we're usually dealing with the positive numbers, so we don't really have to go negative. But just to make a quick sketch, let's say this is 5, 10, 15, 20. Let's just say that's it, all right? I'm going to count by 5s. 5, 10, 15, 20. 5, 10, 15, 20. 5, 10, 15, 20. Just to keep my intervals the same, right? Okay, so what you can do is take 15, go down 2 over 3. We're going to draw our solid line. And everything below that is below budget. Okay, now the difference is here. This one is 19, which is up here. So your slope is down 1 over 1. Down 1 over 1. So your line is going to look like that. Okay, and your answer can be anywhere here that's shaded. To get 19 cases, you're probably going to get somewhere up here. To get 19 cases, you could probably even get more. If we follow the shading part, we can follow what's the most we can do. As long as you're dealing with whole numbers, you have to deal with whole numbers. You can't do decimals here. You have to buy a case. You can't buy half a case. But any answer in here will do. But if they want exactly 19, you would then count how much could you buy with these if I add up my numbers. Okay, so if you have graph paper, use it. If not, just give me your best estimate in your shading. All right.